solving linear systems using the substitution method. So you might be asking yourself, what exactly is a linear system, or what does it mean to solve a linear system? Essentially what we're doing is we are finding the point of intersection between two lines. Once again, when you're solving a linear system, what you're doing is you're finding the point of intersection between two lines. Now you may be familiar with doing this already. You probably learned that you're given two lines, you graph them on a Cartesian plane, and then you find the point of intersection. And there are some coordinates here, x, y, and this is your point of intersection. POI, from now on, POI will mean point of intersection. So yeah, you've probably learned how to do this graphically, but in this series of videos, you're going to learn how to do this algebraically, that is using algebra. Okay, now there are three different scenarios that you may have, right? We're going to look at some examples that have to do with this, where the two lines intersect at a single point. And then you may also have these two other scenarios in which first, the lines are exactly the same, so you could say that there's an infinitely number of points of intersection here, right? There are many, or essentially the lines are the same, right? And you could also have this case scenario where the lines are parallel, and when the lines are parallel, as you can see, there's no point of intersection. So you can add this to your notes: no point of intersection. Okay, let's start looking at our first example. Example 1, it says, find the coordinates of the point of intersection for the following linear system. So you have the following: y equals negative x plus 8 and x minus y equals 4. So the first thing I suggest is to label each of these equations. So we're going to label this as our first equation and second equation. So the method of substitution, it involves first you solve for one of the variables on one of the equations. In other words, you choose one of the equations, one of the lines, and you solve for one of the variables. You can solve either for x or for y, right? Now in this case, for equation 1, they have already solved the equation for the variable of y, so we're just going to use that. So our first step would be, we're going to substitute equation 1 into equation 2. So our first step would be solve equation 1 into equation 2. So let's do that. So equation 2 is equal to x minus y equals 4. So we write x minus, now y, we're going to write this value here, minus x plus 8 equals 4. So once we substitute it, the next thing is to solve for the variable of x in this case. So we're going to expand and simplify and whatever we need to do in order to solve for x. So let's do that. Next, what happens here? X, we have a minus in front of the brackets, so negative times negative becomes positive x. Negative times positive becomes negative 8 equals 4. So we add the 2x, the x is here, so we end up with 2x. And then minus 8, you move it to the other side, it becomes plus 8. So 4 plus 8, that's going to give us 12. And then 2x equals 12. Right? When we solve for x here, x is going to be equal to 6, right? Because 2 is multiplying, it goes dividing on the other side. So 12 divided by 2 equals 6. So we found our x coordinate, or that point of intersection between these two lines. Now we can use this to find our y coordinate. So our next step is actually put a box around this for now temporarily so that we know that it's important. Now we're going to substitute x equals 6 into equation 1 and solve for x. So I'm going to start doing that here. So the next thing would be sub x equals 6 into and by the way, we can choose either equation 1 or equation 2. Since we already have our x coordinate, we can use either equation 1 or equation 2. It doesn't matter which one. I'm going to use equation 1 because it's already solved and it's much easier, but you could use equation 2 and solve for y, and it should give us the same answer. So sub x equals 6 into equation 1. So let's do that. So y equals negative 6 plus 8, right? And now we solve for y. So y is going to be equal to minus 6 plus 8. That gives us 2. So that's our next coordinate. So that means that our point of intersection, therefore, our point of intersection is 6, 2. Now, we're not required to graph this, but if you were to do a rough sketch of this, you would essentially end up with the following. Just doing a rough sketch, but essentially, you know, you draw one of the lines and it will go this way, and the other line would come this way, right? And our point of intersection will be there, 6, 2, right? This would be our equation 2, I believe, and this could be our equation 1, our first line, our second line.